Okay. Good afternoon. Uh, let's start our lecture. By the way, for the webcast, I think because I changed the module code to ST2334_1, so it's only accessible to Group 1 students. So the webcast is not linked to that web page yet. It was originally linked to ST2334, but now I was told that now ST2334 web page or website for this Luminous, there are also webcasts, but webcasts for different lecture group. I don't know, it seems so complicated. I will try to ask for the webcast to be loaded in this website ST2334_1. But just in case there may be some problem and then miss the webcast for 1 or 2 lectures. So you better attend the lectures. Second thing about the midterm test. I told you it's Saturday, so I understand that there at least there are 2 modules have the midterm test on that day in the morning. So I want to know how many of you will have this time clash of midterm test 9th of March, Saturday morning. Please show hands if you have this problem of clash with your modules, your other modules test. Okay, so I want to have some idea how significant the clash is. So we have to make arrangement or do something. All right. Of course, maybe it's too late. If not, one way is to change the time to evening of the weekdays. And most likely it will be 9 o'clock. Because I want to make sure that everyone can attend 9 o'clock in the evening. Yeah. Oh. All right. So I mean, there are all kinds of possibility. But at this moment, the tentative time is still Saturday morning. All right. We have not finalized yet, but I just have some idea how many of you will be affected by the clash. All right. Tutorial start next week. All right. Any problems about tutorial registration except those exchange students? If no, okay. 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 I want to try something not new, but I want you to participate in the survey. Do it now. So the way that we do it is that what happened? I don't know whether you have done it before. I will ask you some questions later on. All right, it's a multiple choice or true or false. So either you SMS, you have unlimited number of SMS, right? This number, I see whether it works, 76767, and then with a space, and then type your answer. If you don't want to use your phone, you can visit this web page or website. All right. Okay. So here is my simple questions. All right. Okay. So you have 2 events, A and B. Okay. The probability of A or B equal to 1. So what happened? Yeah. Okay, so the question is whether A and B must be mutually exclusive. So is it true or false? So what you have to do is to type send SMS to this number and then type the answer. The code is ST23348, referring to this question. All right, lowercase for ST. And then with a space, then type either true or false, depends on what you think, whether this statement is true. If probability of A or B equal to 1, then the A and B mutually exclusive. All right? So simple questions. So what do you think? Yes or no? That means true or false. And then you type in your answer. I want to know whether it works or not. All right. Six seven six seven 76767. All right. 233 ST2334A, then space, then type capital letter T or capital letter F, depends on what you think about the answer. Okay. I think it's enough time. So let's see. A. Okay. Okay. So I have 59. So let's see. So 47 out of 58 say, or 58 say false. And 11 say true. All right. You say when you say true, that means it's true for any two sets A and B. So what you need is to think of whether there's any counterexample. A counterexample just to disprove that. Think of it, can I have B or A being the probability of A equal to 1? Okay, in fact, A and B can be overlap, and then the union of them is equal to the sample space. All right. What? Of course, this time the majority wins. All right, it's false. But why is it false? All right, you think of it. This is the sample space S. So probability A or B equal to 1. So you may think that, oh, this is A and this is B. So they're mutually exclusive. But can I have it like this? All right? So this part is A. All right, this is part A. And then can it possible this is B? So they have something in common, but the union of them equal to 1. It's possible. So in other words, it does not imply that it's equal to, they are mutually exclusive. All right? So, of course, I cannot use this to prove it, but give you some idea that, yes, they may be common, something common, all right, to A and B, but then together, in fact, it's very simple. If A, okay, I already get out. Maybe this picture is not very convincing. Huh? So think of it. A are the odd number 1, 3, 5. B, all right, 2, 4, 6. Wow, so they are mutually exclusive. But let's say B is 1, 2, 3, 4, 6. All right, so A union B is equal to the whole sample space. And they also have overlapping. The intersection is not empty set. All right? So the answer is false. I have more, but I think I skip and start our lecture. Of course, it shows that some of you still have some misconception about this A union B equal to the sample space, and then automatically think that they are mutually exclusive. Okay, so let's start our lecture today. Okay, now we are talking about the sample space with the sample points. That means every element, every outcome are equally likely. Why we have to do that? Because once you have these sample points which are equally likely, then it implies that basically you just do the counting in order to compute the probability. So, all right, so let's consider experiments with outcomes A1 up to AK, K possible outcomes, all right? And we assume that they're equally likely, then each one will have equal probability. If there are K outcomes for the whole sample space, that means each of these will have a probability 1 over K. All right, 1 over K. Now, so then for any event A, basically you just need to count how many distinct outcomes in this event A. So count the sample points, basically count the number of outcomes in event A, divide by the total number of the sample space, the all possible outcomes. So that is a way that we will use, a method that we will use to calculate the probability of an event. So make sure that it's equally likely for each of the outcomes. So here are some examples. So toss a coin. So we have these two outcomes that we're interested in, and this covers the whole sample space, head or tail. And they're equally likely. So each one should be 1/2. All right? So a die. So if the event, okay, the sample space in tossing a die is 1, 2, 3, 4, 5, 6, 6 outcomes, 6 sample points. And each of them are equally likely. So it's 1/6 for each one. Or there are 6 possible outcomes. And then numbers greater than 4 is our event A, which consists of only 2 sample points or 2 outcomes, 5 and 6. So the probability is 2. This is the number of A. Now, this means number of the sample points in A is 2. The number of sample points in the sample space is 6. 1, 2, 3, 4, 5, 6. So it's 2 over 6. So if the outcomes are not equally likely, like toss or biacons, like for example, the head is twice likely as the tails, then we cannot simply use the counting method. All right. So in this case, probably the head is 2/3 and the probably tail is 1/3, which we have already discussed it before. Okay, so another example, we have a box. Inside the box, there are 2 types of objects. One is the bolts, the other is the nuts. 50 bolts and 150 nuts. All right, and we know that half of the bolts are and half of the nuts are rust. All right. So now, if one item is chosen at random, what is the probability that it's rust or is a bolt? So, so in this case, the experiment, or what we consider is that we just select one item from this box. So what is the sample space? The sample space will be any one of these 1,200 items, 15 bolts and 150 nuts. All right? We select one item. So the possible outcome is 200 because there are 200 items. 200 items. So each item are equally likely to be selected. So now we ask, what's the chance that it's either a rust or bolt? All right, so, so in this case, let's assume A is the item being rust and B is the item being a bolt. All right? So how many items are rust? So you can work out that half of it, that means 25 rust bolts and 75 rust nuts. Half of it, half of this number. All right? Half of 50 and half of 150. So altogether, there are 100 items in the box that are rust. All right. In fact, alternatively, you can think of it like this. Because they say half, half. So basically, we add together, that means half of the items in the box are rust. So which means 100. And how about the item that is a bolt, which is 50? And so we applied what we learned. Okay, okay. So we use this formula, which we have discussed when we talk about basic properties of probability. So probability of A is 100 items that favor to the event A divided by 200. So this one, 50 divided by 200. And A intercept B. This one, how many is rust as well as is a bolt? So half of it, half of this 50 are rust. So it's 25 over 200. So we apply the properties of probability A union B, which is the sum of probability A plus probability of B, then minus probability A intercept B. So the answer is 5x. Of course, alternatively, you can think of it like this. You select the items. So the items is either a bolt or nut. All right? I try to identify the items using two variables or two characteristics. One is what type of the item is it, whether it's a nut or a bolt. The other one is whether it's rust or not. All right? Rust or it's not rust or non-rust. So altogether, there are 4 possible categories. All right? So we know that there are 50 bolts and 150. And out of this 50, 25, half of it are rust, so the other half are non-rust. So it's 75, 75. So what does this 25 mean? This means 25 items or objects in this box are rust as well as it's a bolt. All right? So when we say A or B, that means it can be a rust item or it can be a bolt. So it's rust item, so that means it can be this one as well as this one. Sorry, not this part. All right, but this one. So it's this part gives you rust. This part gives you bolt. In fact, it is rust plus bolt, but this item is double count. That's why we have to subtract this 25. All right. So that's another way to look at it. of course, using this formula will be easier instead of looking at the table, but the table may give you a better idea as what's going on. Okay, another example. So we throw 2 dice, fair dice, and what's the chance that the sum of the 2 numbers equal to 8? So we work out. Now, in this case, we use an order pair. I try to use a parenthesis to represent something is ordered. So when you say 1 and 2, or A and B, it means the first outcome is a A and second outcome is a B. The order is different. So this is considered as 2 different outcomes. Well, if I write it like that, the order is not important. It's just a set consists of these 2 items, A and B. So it doesn't matter whether it's A, B, or B, A if you have this curly bracket. All right? So is it curly bracket? What do you call this one? So this one is parentheses. Okay, so if this means just a set with these 2 items. So here, the sum equal to 8. So the first die, or maybe first is not very good. I just try to color these 2. So one is red, the other is blue. So the first one represents the outcome of the red. The second one represents the color, the outcome of the blue die. All right. So 2, 6, and 6, 2. Although you see, if no color, then the 2 dies have 1, 2, 1, 6. But basically, they represent 2 possible outcomes. One is 2 for the red, and then 6 for the blue, while the other one is 6 for the red, and then 2 for the blue. So these are the possible outcomes that will give you the sum equal to 8. So the number of pawns favored to event A is 5. Then how about the sample space? The sample space is equal to 36. It's 6 times 6. The first outcome has 6 possible outcomes, 1, 2, 3, 4, 5, 6. And for each of them, there is another 6. So it's 6 times 6, so it's 36. All right. Of course, you can write down all the 36 possible outcomes, but there's no need to write down all this. All right. So the answer is 5 over 36. Okay, now, here's another example. 2 balls are drawn randomly, all right, from a box or on, containing 6 white balls and 5 black balls. So what is the probability that one of the drawn ball is a white and the other is a black? Now, in order to solve this problem, does the order of the ball being taken out matter? Can I just ignore the order? In fact, it doesn't matter so long as you remember what you're doing. So let's try, forget about the order. I just take 2 balls. My hand is big enough, I can take 2 balls at one shot. All right, I take 2 balls. So now the question is, out of this box, how many ways, balls, these 11 balls, I number them. All right, so I take 2 balls. So how many possible ways can I take 2 balls? So suppose I label 1 to 6 for the white balls and then 7 to 11 the black balls. So altogether, the possible way to select 2 balls out of 11 balls. This is the way. Choose 2 out of 11. And we just grab the 2 balls. We don't care which one comes, we don't consider which one comes first, which comes the second. Then, in order to get one black ball and 1 white ball, how many ways can we do it? So we divide these 11 balls into 2 groups, 6 and 5. 6 white ball and 5 black balls. So choose 1 from 6, choose 1 from 5, and multiply them. Why multiply them? Because any way, one for each way that you choose 1 black ball, there are 5 ways that you can choose the white balls. So altogether, the answer will, this is the number of ways that you can select. All right. So this one is choose 2 out of 11, choose 1 out of 6, and choose 1 out of 5. So the answer is 30 over 55. Of course, you can simplify it. So it's 6 over 11. All right. Now, what happens if I consider the order? Consider the order. All right. So in other words, now I consider the order. So I have to choose 1 ball out of 11 balls, and then choose 10 balls out of the remaining 10 balls. Choose the second one. So this is the number of ways that we can select 2 balls. All right? Right? There are 11 balls. I labeled it 1 to 11. So I take 1 ball out, record down it, whether it's black or white. All right? And then take another ball. Or you can record down the number. So if order is the order is being considered, the number of sample points will be 11 times 10. Then how about drawing the balls? Now I take 1 ball from the box and then followed by another one. So in order to get 1 black and 1 white, so I may select a black ball first. So it is 5, choose 1 out of 5. And then the remaining one, right? In the box, after I select 1 white ball, there are 4 white ball. Am I right at the number? I'm sorry. Select 1 black ball. 5. Okay. So it's correct. So now, after I select 1 black ball out of the 5, inside the box, how many balls are there? 10. 4 black balls and 6 white balls. But what I want is to get a white ball. So I can only choose 1 out of the 6 white balls. So this is the number of ways that you choose 1 black ball first, followed by 1 white ball. But this is not the whole thing. You still have to consider, choose 1, this is 1 white ball, followed by 1 black ball. All right? It looks similar, but what it means is that I choose 1 ball out of the 6 white balls, and then followed by 1 black ball out of the 5 black balls. Are these two mutually exclusive? That means if one happens, the other will not happen, right? If the first ball is the black ball, then it cannot be the white ball. So you have to add these 2 together, because both of this number of ways will give you 1 white and 1 black. All right. So what does it mean? It means that your answer will be this one as the numerator and this as the denominator, and it will give you the same answer. So what I mean is that why take the longer way, consider the order, if the order in this case doesn't matter? All right. So in that case, I just think of it as I grab the 2 balls together. How many ways can I get 2 out of these 11 balls? And out of these so many ways, how many will give you 1 white and 1 black? And disregarding the order. Okay. All these are very straightforward example. So now I have hands of 5 out of a deck of cards. So in other words, my experiment is to select 5 cards. Again, it's just like I just select a set of 5 cards and 1 shot. Don't care about the order. All right, so how many ways can I do it? I choose 5 out of 52. So this is the number of sample space. Now, alternatively, if you consider the order, you make the problem more complicated. So how many ways can you select 5 cards? So it will be 52 for the first card, 51, 50, 49, and 48. So this is the number of ways that you can choose if you're really concerned about the order. When when you concern about the order, means that suppose you got A's 2, 3, 4, 5 in that order. So it will be considered different as A, 2, 3, 5, 4 if you swap the other two. All right? So, but this one, we don't care about the order. So long as I have A's 2, 3, 4, 5, it will consider as the same, just one outcome. All right? So the event is to have 2 A's and 3 jacks. All right? So I have to divide these 52 items, cards, into A's group, jack. Is it enough? I have only 4 A's in the deck of cards. I have 4 jacks in the deck of cards. How about the remaining cards? Of course, there's still the others. How many of them? 44. So I divide these 52 cards, a deck of cards, into 3 groups. Ace, 1 group, jack, 1 group, and the rest, 1 group. So in order to satisfy this event, I need to choose 2 out of these 4. I need to choose 3 out of these 4. Then how many do I have to choose from this? You don't have to choose any. All right? So it's 0. You don't pick any card from the rest. So that is the number of ways that you can select 2 A's and 3 jacks. Now my point is, remember, you have to make sure that you divide your sample space into groups that will cover every aspect. All right? If you drop this one, you still get the same answer, but you miss a very important point, because there are, in fact, 3 groups. You choose from Ace, you choose from Jack. You also have to choose from the rest. But in this question, you just don't have to pick anyone. So that's why you choose 0 from the remaining 44 cards. So you have to put down there in order to make it complete. Otherwise, next time you will be confused on why. You see, if I change this to 2, then what to do? Then you change this to 2. And if you forget about this part, then you only have 4 cards. 2 A's and 2 jacks. Where's the 5th card? The 5th card is supposed to choose from the rest. All right? So in that case, it will be choose 1 out of 44. So if the question is like that. All right? All right. So that's the answer. Okay, so here is just the same thing. I just want you to be aware of that. We are talking about selecting 3 books. Out of how many books? 3 novels, 3 poems, and 1 dictionary. So altogether, there are 9 items. 3 plus 5 plus 1. Or 5 plus 3 plus 1. All right? And, okay, this is the this is the number of books, and you're supposed to choose 3 out of this. So you choose 3 out of 9 books. 3 out of 9 books. All right. 3 books, select from this 5 plus 3 plus 1. So what's the probability of a dictionary being selected? Now, it only specifies a dictionary. So in other words, out of these 3 books, okay, so I have to divide these 9 items into 3 groups. These are the novel, poems, and dictionary. So I want a dictionary. How about the poems and the novel? Did not say anything. So no condition on that. All right? So maybe this is not a good way to describe it. So forget about this one. Divide into 2 groups. Dictionary group and non-dictionary group. All right? So you see, I modify a bit. I don't care about choose how many from the 3 novels, how many choose from. I mean, how many should I choose from the 5 novels, and how many should I choose from the 3 poems? So I just choose 1 dictionary from this dictionary and choose the rest. That means 2 from the 8 non-dictionary items. Now, this one, we specify how many novels, how many poems that we need. So this time I have to divide into 3 groups. 5 novels, 3 poems, and 1 dictionary. So I want to have 2 novels and 1 book of poem. So of course, 0 dictionary. The dictionary should not be included. All right. So this is the number of ways that we select on event A or event B, let's call it. So this is the number of ways that you select A. So this is number of S. So probability of A will be this one divided by this. Probability of B is this number divided by number of S. All right, so that's what we have. So this is choose 3 out of 9, 84. And choose 2 out of 8 and then 1 out of 1, so it's 28. So the answer for the first one is 28 over 84. While the second one is to choose 2 novels, so it's choose 2 out of 5, 1 out of 3, and then 0 out of 1. So the answer is 5 over 14. All right? This is not so obvious, so it's interesting. So this professor presumed to be me. So I let you have 10 topics, all right? So I'm going to pick 5 topics to set questions on these 5 topics. Randomly choose 5 out of these 10. So the number of topics appear in the test, the number of ways that we have these 5 topics out of these 10 topics, all right, will be choose 5 out of 10. Right. So this student may be a normal student, so don't prepare all 10. So prepare only 7 topics. All right. So of course you hope that all the 5 topics appear in the test will be will be among all the among these 7. All right. So so this professor chose 5 topics at random. So what's the chance? What's the chance that this student's able to answer, get all the 5 topics appear in the test that prepare for all these 5 topics? So now ask yourself, I have 10 topics, all right? So I'm talking about this event, all right, all 5 topics. So how I'm going to divide these 10 topics into groups? How many groups? And how to identify these groups? All right, so of course, we divide it into 2 groups. One group consists of all the topics that the student prepare. Am I right? So 10 topics. So this one is the prepared one, and this one is not prepared. All right. Okay, so this is the scenario. So the professor will randomly select 5. So in order to able to answer all the 5 topics or get the 5 topics, so we hope that the professor will select all the 5 from this group, right? And select how many? None from this group. All right? So it's important that you're able to identify these 10 topics into relevant groups in order to answer the questions. So in this case, we're interested in whether the student prepare, how many he prepare. So we divide it into 2 groups. 7 are those topics that he prepare, and 3 that he does not prepare. So choose 5 out of 7. So this is the if I call this event A, so this is the number of counts, number of ways, or number of sample points, number of outcomes for event A. So over the number of S, that will give us that probability. So less than 3 topics. So this student prepared less than 3. Not including 3. Less than 3. That means he's so unlucky that he only able to, out of these 5 topics, he can answer 0, 1, or 2 topics. So in other words, if your answer can only get 0 topics, so if it's 0, this one should be 5. But it's not possible. Forget about it. Similarly, for 1, topics, then this is 4, also not possible. Then next one, so forget about it. Then 7, we choose 2, and then 3, choose 3. So that will make it to 2 topics that he got it, but the other 3 he did not study and appear in the test. All right? So we go to 3. This one. This is not meet the criteria, less than 3 topics, because this one is exactly 3 topics. So you only have 1. Supposed to be 0 topics, 1 topics, and 2 topics. But it's not possible to have 0 topics and 1 topic, since he's already worked very hard and prepared for 7 topics. So at least he's able to answer some. All right? It cannot be 0 topics. All right? Exactly 4 topics. So that is easy. Exactly. So I don't have to worry. So choose 4 topics that he answered, and then 1 topic out of what he did not prepare. So that is the number of possible ways to get exactly 4 topics. All right, so that's the answers. So all right. So you can see that. Choose 4 out of 7. Choose 1 out of 3. Okay. This one, it makes life easy. In fact, in real life, it may not be that easy. We only have 2 characters about, or two subjects for these students, either chemistry or economics. So he can, okay, out of these 200 students, 108 study economics, 138 study chemistry, and 70 study both. So, so it's very obvious. Our sample space is these 200 students. So we pick 1 students, all right, and then ask, what's the probability that the students take economics or chemistry? So you can consider this one is to ask probability of economics union chemistry. All right. So, so we know that probability of economics is 108 over 200. Probability of chemistry is 138 over 200. Probability of N, intercept C is 70 over 138. So to get this answer is very straightforward. Just apply the property of probability. But then this one doesn't take neither of these subjects. What does that mean? It means that this is, they take either economics, either chemistry, or chemistry. That means you can just take one of them or both of them. So the complement of it means that you don't take any. So it's, you won't see, you see, if I draw the Venn diagram, it will be like this. E and C, all right? E and C. Then this means that those who do not take any one of these subjects. So it's outside this E and C together. So it's E union C complement. Now there are 2 ways to get this probability. One way is that this E union C complement in fact is equal to E complement intercept C complement. This is harder to understand, but this is another way to do it. But there's an easier way. Because this probability is equal to 1 minus probability of E union C. And probability of E union C, we can get it from part A. So it's just 1 minus the answer from part A. Instead of using this formula, all right, you still have to look for what is probability of E complement and E C complement, and then look at the intersection. So it's very complicated. So we better use this formula. So that's why I stress that you should get, if you know how to get the answer, try to get another way. So sometimes a particular way may be easier for you to get the answer. So we use that. Okay, this one takes chemistry but not economics. So in other words, we need chemistry, but we don't want economics. So we want to find this probability. So how? So if you remember, C can be written as union of two sets, C intersect E and C intersect E complement. So the union of these two will give you C, right? This part means that those C, the C you divide into two parts. One is common to E. The other part is common to E complement. That means the part that does not overlap with E. All right, so this is this part. So the two combined together is your C. And probability of C, we know that this is probability of C. Probability of C intersect E, we also know that. So immediately we know that the probability of C intersect E complement is probability of C minus probability of C intersect E. All right? Probability, because these unions, these two sets are mutually exclusive, so probability of C equal to probability of C intersect E plus probability of C intersect E complement. All right? So that is how you get the answer. So you can read it. All right? Okay. Conditional probability. This is very useful and also a little bit more complicated than all the previous topics. All right. Okay. Why we have such thing? Because sometimes we may have partial information about certain events has occurred. So with this help, with this new or additional information, will that help us to evaluate the probability of certain events? All right. So in other words, if I have two events, all right, probability of A, all right, that means I don't need any information about B. But what happens if I know B has occurred? So what is the probability of A? This means that we know, okay, still probability of A, but it's different A now because it's simply saying that I know B has occurred. So what is the probability of A occurred? A very simple example is like this. If A is 135, right? A is 135, tossing a die, 135. So what is the probability of A? So I toss a die, what's the probability of getting an A? It's 1/2, all right? Now, suppose I toss it, and then I know that the number is less or equal to 3. It is 1, 2, or 3. All right. I did not tell you what the outcome is, but I tell you that, okay, the outcome is a number less or equal to 3. So, do you still believe that the outcome is an odd number or belongs to A, is half? I look at the outcome is less or equal to 3, so it means 1, 2, 3. Out of these 3 outcomes, 2 of them are odd numbers. All right? So in other words, now the chance is not 1/2, but instead it's 2/3. 2/3. All right? So this is what we mean by conditional probability. That is, we look at a probability of an event, but conditioned on some other information. That means another event, condition on another event. So that may or may not be the same. Are they equal? So my example will illustrate that they are not the same. But can they be the same? Can they be the same? Yes. Under certain conditions, they are the same. Let me change. Now I told you that, sorry, I make a mistake. The outcome is a number less or equal to 4. Less or equal to 4. Not less or equal to 3, but less or equal to 4. So now B is 1, 2, 3, 4. Then out of these 4 outcomes, how many of them are odd numbers? 2. 2 out of 4. So it's still half. What does it mean? It means that what I told you, the outcome is less or equal to 4, does not change the probability of A. So the condition probability of A given B, that means with this new additional information about the event B, does not change the probability, does not make you change the probability of A. So in that case, this probability of A and probability of A given B are the same. All right? So that's the hard part. Sometimes they're the same, sometimes they're not the same. So it depends on the problem. All right. Okay, so this is what we mean by probability of A given B. So it's conditional of event A given that event B has occurred. All right. So remember, all this, we are still talking about probability of an event A. Only one without any referring to the event B, while this one condition on B. That means B has occurred. Okay, so here is an example. So x1, x2. So there are 36 sample points in the sample space. Let's say event A is the sum of the number equal to 10. So there are 3 sample points that give you the sum equal to 10. All right? So probability of A is equal to 3 over 36. While event B is x1 bigger than x2. x1 bigger than x2. All right? So it's 2, 1, all right? 3, 1, 4, 1, and so on. How many numbers are there? So you write down, you spend some time to write it down, and maybe you make a mistake. All right? Now you can think of it. You have 36, 6 times 6. x1, 1, 2, 3, 4, 5, 6. x2, 1, 2, 3, 4, 5, 6. So altogether, 36 of them. Think of it. x1 greater than x2. So this is the line, the point, 1, 1, 2, 2, 3, 3, right? So 6 of them in this diagonal. And then, how about all these points? So this is 1, 6, all right, 1, 5. x1 equal 1 and x2 equal 5 and so on. So these x1 are less than x2. Only this part are those with x1 bigger than x2. x1 bigger than x2. Now, so how many of them? So altogether there are 6 by 6, 36. Minus the diagonal. How many elements in the diagonal of this table? 6. 1, 1, 1, 2, 3, 3, 4, 4, 5, 5, 6, 6. Minus 6. So the remaining is 30. And half of them x1 bigger than x2. Half of them x1 less than x2. So 30 divided by 2. So it's 15. So there are 15. Number of B is equal to 15. All right? Okay. So these are the probabilities that we can work out easily. So now the question is that, okay, if I tell you that, okay, the probability, so we know that the outcome, all right, of these two, showing these 2 dice, all right, the outcome that belongs to B. That means we know that the first number is bigger than the second number. So, all right, so then what is the probability of x1 plus x2? So we count. So you count out of this 36, 15. Out of this 15 of them, all right, how many of them belongs to x1 bigger than x2? So you can see that x1 bigger than x2 with the sum equal to 10, only 1 point. All right? Only 1. That means only there are 6, 5 here. This one, x1 is bigger than x2, but the sum is not 10. So next one is 6, 4. So 6 plus 4 is 10. Then the next one is 6, 3 is not. The sum is not 10. So only 1 out of this lower triangular, all right, one outcome out of the 15 of them is the sum equal to 10. So the answer, okay, is, okay. So the answer is 1 over 15. But how do we know that? So what we are trying to do is that, okay, I know that B has occurred. So basically just now I look at all the 15 possible outcomes. Now I'm not looking at the 36. I'm looking at only 15 because I was told that the event B has occurred. The number x1 is bigger than x2. So I look at this 15. Out of this 15, I see how many favor to A. That means the sum equal to 10. So in other words, I need to figure out how many that are belong to B at the same time belong to A. All right? So that is the one that belongs to A as well as belong to B. And then my sample, my denominator will be the number of B. Look at how many, because I know that B has occurred. So only look at these 15 sample points. Out of that, only 1 point that favor to sum equal to 10. So if I divide this by the sample space number, then this is probability of A intercept B plus over probability of B. All right, so this is the definition of conditional probability. If you want to define the probability, it's saying that, okay, now the probability of A given B is equal to probability of A intercept B divided by probability of B. That means basically it's like this. Okay, at first you look at this probability A divided by the S. But now you are not looking at S, but instead you are looking only at B. All right? Then you look at the part that belong to B at the same time belong to A. So that's why you look at A intercept B, and your denominator is the number of sample points in B. So that's why it is probability of A intercept B divided by probability of B. So similarly, if I say that B intercept condition on A, then it will be probability of B intercept A divided by probability of A. Just remember, the denominator is the probability of the occurrence of the event that you condition on. All right? So, so here's an example. All right, so the A intercept B is just 1 point, 6 and 4. So the other one, 4, 6 and 5, 5. These are not belonging to B because these two points, sample points, do not satisfy the x1 bigger than x2. So they are out. So only 1 point, 6, 4. All right, so number of them is 1, and therefore the probability of A condition on B is 1 over 15. And how about B given A? So this is how to interpret this one. Now you are told that, okay, the outcome, okay, the two outcomes has the sum equal to 10. So you can forget about the many of the sample points. Only 3 sample points. The 5, 5, 4, 6, and 6, 4. 3 points. 3 sample points. That will give you sum equal to 10. And look at these 3 sample points. How many of them give you x1 bigger than x2? 1. So this is 1, and this is 3. So that's how 1 over 3. 1 over 3. So immediately you know that these two are not the same. These two, not just the answer are not the same. In general, these two means different things. One is the first one saying that probability A given B, saying that B has occurred. What's the chance that you got an A? While the other one is A has occurred. What's the chance that you got a B? So they are two different events, 2 different conditions. What is this probability? So it means that I know that the outcome is have a sum equal to 10. The two dice have a sum equal to 10. So what is the chance that B prime means that x1 is less or equal to x2? B is x1 bigger than x2. So B prime, now B is x1 bigger than x2. So B prime are those pairs such that x1 is less or equal to x2. All right. So in that case, there are two of them, 5, 5, and 4, 6. Okay, so it's 2 over 3. All right. So, so they add up this probability of B given A and probability of B complement given A, add up equal to 1. Is that coincidence or is always true? You see? 1/3, 2/3, add up equal to 1. So these two add up equal to 1. Is it always true or just by coincidence? It's always true. It's always true. Okay? So long as your conditions are the same, both are conditioned on A, that means A has occurred. Then you look at what's the chance that you have B occur or B complement occur. So these two are complement of each other. All right? So they should add up equal to 1. They should add up equal to 1. Is it correct? In general, it's not correct. Condition on a different conditions. The first one is probability of B given A. You know that A has happened. What is the chance that you got a B? But the second one is that I know A complement occurs. So what's the chance that you got a B? So it's different. All right? It's because the condition changed from A to A complement. So they are not necessarily the same or complement of each other. So you have to be aware of that. All right? So, this is not true. So don't confuse the thing. So conditions are the same. Then B and B complement with this complement of each other, the probability. All right. So this is how we define the conditional probability. B given A is probability of A intercept B over probability A. Although you don't care most of the time, but you have to be aware of that. It means that probability of A does not equal to 0. What happened to 0 if probability A equal to 0? Mathematically, you cannot put a 0 in the denominator. And also, this also means that it does not make sense to condition on something that never happens. All right? The probability interpretation is that you cannot condition on something which never occurred. All right? So it does not make sense to talk about that. So we make sure that probability A has to be different from 0. Okay, because this basically, this is a probability of event B, but conditioned on something. So it still satisfies all the basic properties about probability. So this probability of event B given A has to be between 0 and 1. All right. And probability of S given A has to be 1. All right. Because A is a subset of S. So therefore, probability S given A is equal to 1. So, in other words, it doesn't matter whether A happens or not. Probability of S is always 1 because it covers everyone. All right. So like toss a die. All right. So what is the chance that you got 1, 2, 3, 4, 5, 6? 1. Any one of the numbers, the outcome must be 1, 2, 3, 4, 5, 6. So now I tell you, okay, I toss the die, and the outcome is less or equal to 3. What's the chance that you got 1, 2, 3, 4, 5, 6? You don't have to tell me 1, 2, 3 has occurred. It has to be 1. Any one of the numbers 1, 2, 3, 4, 5, 6 must occur. All right. So That's how we interpret it. Although you can see that S is A is a subset of S. All right, so but this simply means that we still hold that probability of S equal to 1. So same thing, if B1, B2 are all mutually exclusive, then all the union of this BI's conditional A is equal to the sum of the conditional probabilities. All right. Okay. So in particular, if these two are mutually exclusive, then the union, the probability of these two union is the sum of the two probabilities. Okay, so so we similar to what we discussed. Now we roll two balanced die. The first die is 3. What's the probability that sum of the two dice equal to 8? So there are two events mentioned here. Event A, first die is a 3. So that means we are talking about 3-1, 3-2, up to 3-6. The second is the two dice, the sum equal to 8. So it's 1-6. 1-6 cannot be 8, so forget about it. So start with 2, 2-6, 3-5, 4-4, 5-3, and 6-2. So these are the possible outcomes that will give you sum equal to 8. So what is the probability that you got sum equal to 8? All right. So you look at it. So this is supposed to be the sum equal to 8. But now, okay, let me call this B. So basically we are asked, what is the probability of B given A? This is B, the sum equal to 8. So look at it. Probability of A intercept B. That means it has to be, the first must be 3, and the sum equal to 8. There are only 1 point. So this one equal to 1 over 36. And then the probability of A is 1 over 6. So the answer is 1 over 6. All right? Or in terms of, okay, I try to work out based on the probability. So I work out the probability A intercept B. So that means I have to know how many sample points belong to A intercept B. Only 1 point. 3, 5. All right? So the probability is 1 over 36. Only 3-5 out of 36 outcome that will give you A intercept B. Probability of B is 1/6 because you only need the first one to be a 3. The rest can be any numbers. So the answer is 1/6. All right? Okay, unbalanced die. Unbalanced, so the probability are not the same. You must check whether this sum of the probabilities 1/12, 1/12, 1/6, 1/6, 1/6, and 1/3 add up to 1. If it does not, if all these numbers do not add up to 1, what does it mean? It means something wrong. Either there are another possible outcomes that we did not take care, or these probabilities are wrong. All right? They have to add up equal to 1. Why they have to add up equal to 1? Because I said so, right? Why it has to be add up equal to 1? Because the die have these 6 outcomes. These are all possible outcomes. The set of all possible outcomes is these 6 numbers. So corresponding to these 6 sample points, the probability should add up equal to 1. But it's not all the same, but they have to add up equal to 1. So you check this. All right? Then, okay, if the number is obtained is even, what is the probability that it is a 6? All right? Oh, so easy. They have 3 out of 6 is even. 6, so it's 1/3. Right? Is it correct, Confused. 1/6. Because you have 6 numbers, right? So even number means 2, 4, 6. And 6 is one of them, so 1 out of 3. Is this correct? Is it correct? If you think it's correct, then my next question is, so what happened to these numbers? 112, 16, and 130. What happened to these numbers? Your 1 over 3, all right, is based on the assumption that they're equally likely. But here it's not equally likely. So in other words, you cannot simply just count. You really, really need to compute. So this one, let me call this A, even numbers. And B is getting a 6. So we are asking, what is the probability getting this one? All right? So it's probability of A intercept B divided by probability of A. Probability of A means that what's the chance that you got an even number? Getting an even number means that you got 2, 4, and 6. So the probability getting 2, 4, or 6 is equal to 112, adding 1, 6, and then adding 1, 3. This is the probability of getting an even number. All right? And A intercept B means that it is only this part. So probability of A intercept B is equal to probability of B, or just a 6. So it's 1/3. While probability of A is 112 plus 16 plus 1/3. So this is the answer. All right? So 112, 16, 1/3. That is the probability of A. And probability of A intercept B is 6. All right? Because B is a subset of A. So it's 1/3. So the answer is 1/3 over 7 over 12. So the answer is 4 over 7. 4 over 7. All right? So it is more than half of a chance to get a 6. If we know that all the numbers are even. It's not 1/3, but it's 4 over 7 in this example. So the next question is, what's the probability that the number obtained is a perfect square number, given that the number is greater than 3? So now event C is a number greater than 3. So it's 4, 5, and 6. And event D is a perfect square. What does perfect square mean? It means that it is 1 square, 2 square, and 3 square, and so on. But 3 square is 9. It's already out of range. So we only have 1 and 4. Perfect square. 1 square, 2 square, 3 square, and so on. All right? So in other words, we are asked what is the probability that D given C. All right? So all right. So C intercept D is 4. The probability of C is equal to 2/3, and while the probability of C intercept D is 1/6. So the conditional probability of D given C will be 1/6 over 2/3. So the answer is 1/4. So if we know that a number is greater than 3, then what's the chance that it's a perfect square? There's only one outcome. That means 4. So in other words, given that the number is greater or equal to 3, or greater than 3, what's the chance that you got a 4? So the chance is 1/4. I have 2 children. And if we know that there's at least one son, then what's the chance that both are boys? They have 2 kids. So what is the sample space? This one, should I consider Two boys, two girls, one boy, one girl. Is that the sample space? Huh? One boy, one girl. The question is, do I have to consider this one? Do I need to consider this one? Huh? No need to consider? Do we need to consider this, the last order pair that I wrote down? Yes? No. Yes or no? It doesn't matter. It matters. Why? If I consider 4 sample points, all right, it means that BB means the first one is a boy, first kid is a boy, second one is a boy. All right? While BG means the first one is a boy, second one is a girl. Yeah, the outcome is still one boy, one girl. But then the fourth one, the first kid is a girl and the second one is a boy. All right? So if you don't care about the order, it's one boy, one girl. But then you can ask yourself, if I drop this one, are all these equal likely? Getting one boy, one girl is the same chance as getting 2 boys. The same chance as getting 2 girls. Am I right? Very simple. If I have 2 coins, a head and tail, I toss 2 coins. Okay? You will bet on 2 heads, 2 tails, or 1 head, 1 tail. Which one will you bet? Of course, I will bet 1 head, 1 tail. Why? Because the chance is higher to get 1 head, 1 tail. Because 1 head, 1 too complicated. Color the 2 coins. All right? Or name it 1, 2. Color the 2 coins. 1 red, 1 blue. All right? You get head. Can be head for the red, tail for the blue, or the tail, the head for the tail for the red, and then the head for the blue. So you have 2 out of 4 chances to get 1 head, 1 tail. So the key is whether all this I wrote down, are they equally likely? So 4 of them, they are equally likely. But if you write down only boy, boy, girl, girl, and boy, girl, they're not equally likely. All right, so so I should include this in. All right, so given that at least 1 son, what's the chance that you have 2 boys? So if I call this A, call this B, all right? B, 1 son means BB, BG, and GB. All this means at least 1 son. A means 2 boys, has to be boy, boy. So the chance is 1/3, right? Because the intersection of A intercept B is equal to A. All right, so that's, all right? So it is 1/3. 1/3. Okay? You see, I have to write down BG and GB because you have to consider equally likely. Okay, this one I think is more or less the same. So we have 2 events. I think I leave this for you to read. All right. How about 5? Okay. So far, the discussion you have to work out the probability. So this one given in a table. So this table, the 2-way tables. That means any entries represent an outcome of 2 variables or 2 factors. One is whether I have hypertension or not. The other one is whether it's a smoker, a non-smoker, a moderate smoker, or a heavy smoker. All right? So there are altogether 180 individuals, and out of this, 21 that have hypertension but a non-smoker. So in other words, the probability, if you select one from this 180, the probability of a non-smoker and hypertension will be 21 over 180. All right. If you select one from this 180, what is the chance that it is a non-smoker? So the probability is 69 over 180. So that's how we interpret this table. All right. So now, if we select one individual, what is the chance that this individual experience hypertension? So it will be 69, hypertension, 87. 87 hypertension out of 180. Then experience hypertension given that the person is a heavy smoker. All right. So in fact, it is very straightforward. Heavy smoker. So I forget about the rest, 180. I just look at the heavy smokers, 49 of them. What is this 49? This 49 is the probability of having a heavy smoker. Probability of having a heavy smoker is 49 over 180. And what is the chance that out of this, he's a hypertension patient? So it is the probability of heavy smoker hypertension, given that it is a heavy smoker. All right, so it has to be the intersection. The intersection is 30. This and this is 30 over 180 and 49 over 180. So it looks as if I just count out of these 49 heavy smokers, how many of them are hypertension patients. So it's 30 over 49. So with these tables, it's much easier to work with than you work on the conditional probabilities definition. Okay, what's the third question? Given that the person is experiencing no hypertension, what is the chance that it's a non-smoker? So, non-smoker, no hypertension. So I look at all the people with no hypertension. So I can ignore the rest. I just look at this 93, and then non-smoker is 48. So it's 48 over 93. All right? So that's how you get the answer. But I will ask you to check using the definition. So the part C is, what is the probability that given that no hypertension, what is the chance that it's a non-smoker? All right, so this one is the probability of a non-smoker and no hypertension divided by the probability of no hypertension. So use this to work out the probabilities, and they should be the same. It's 48 over 93. All right, so okay. So 6. Yeah. Okay, skip 6. 7. Also quite okay. We work out this probability, but the point that I want you to, besides work out the probability, check this two and check this and this. All right? I told you at the beginning when we talk about conditional probability. So A and B, all right? The two should be add up equal to 1 because B is a complement of the event B complement. While A and C, all right? A is a complement of A complement. But you cannot add this answer of A and C to add up equal to 1 because the conditions are different. That's the point that I want to stress. If the conditions are different, all right, then your answer, you cannot treat the answer the same or different. All right? So you have to work out all this probability using the definition. So, for example, this one is probability of B intersect A complement divided by probability of A complement. So you have to work out this one, you have to work out this one. Now, in order to work out this one, sometimes you may need probability of B minus probability of B intersect A. All right. Why? Because you can think of it B. You divide into two non-overlapping parts. B common to A and B common to A complement. So it's equal to the sum of these two probabilities. So therefore, probability of B intersect A complement is equal to probability of B minus probability of B intersect A. So this will help you to compute all these probabilities. All right, so you can do it yourself. Okay, so I think I have to stop here and continue next week. Today is Tuesday, yeah, next week. So tutorial start next week. All right, next week.